All right. I'm just going to draw a picture to justify why it works this way, and then I'm just going to do a few examples. So 2 things to know. Addition means combine and count. And a fraction is an equal part of a whole. So if I have to do something like take 1/2 and add it to 1/3, well, I have 1 and another 1. I can't really say that's 2 because they aren't equal parts. So if I draw a picture of 1/2, it could look like this. And if I draw a picture of 1/3, it could look like this. Right? And a third is not the same size as a half. So it doesn't make sense to say there's 2. However, if these are cakes, I can recut the cakes, right? So if these were cakes and I gave one kid this piece and I gave the other kid that, there's going to be blood, right? They're going to fight over it. So to make sure, I would cut the halves cake in thirds and the third cakes in halves. Now I can say, oh, well, I also, instead of a half, I could call it 3/6. And instead of a third, I could call it 2/6. How many pieces do I have altogether? 5. They're all the same size. What size are they? They are all 6ths. So my point is, because addition means combine and count, and because a fraction is equal part of a whole, you can only add if you have a common denominator. And it turns out subtraction works the same way. So I'm going to show you what I think is the easy way to add and subtract fractions, and then maybe I'll show you the hard way. But we'll probably just stick with the easy way. Okay, so bottom line, addition and subtraction has to have a common denominator. All right, Morgan, give me that problem you were looking at a minute ago.
Minus 1/8.
Minus 1/8. Okay. I'm going to do a plus version, then I'll do the minus, if that's okay. So I'm going to do this one first, and then I'll come back to a minus. Okay, so they're not the same denominator. So I can't just add. It doesn't work. The quick way to come up with the denominator is to just multiply whatever you see. What's 6 times 8? 48 on a good day. Now, then what I have to do next is do a cross multiply to adjust. 8 times 1 is 8. 6 times 1 is 6. I'm adding these. What am I adding? Well, 8 and 6, which is 14 on a good day, out of 48. So this arrow method gives you a quick answer when you're adding or subtracting. Now, I have to reduce. Let's see, they're both even, right? So I can divide by 2. I highly recommend writing in the divide by 2 instead of just thinking it, so you have a record of what you did. So that's going to be 2 goes into 14, 7, 2 goes into 48, 24. Pretty sure 7 does not go into 24, goes into 21 or 28. So that should be the final answer.
So you multiply each cross?
Yeah, so what you do is you multiply the denominators, and then you cross multiply the denominators into the numerators. And it works for addition or subtraction. So I'm going to do it next for the subtraction problem that Morgan asked about. Same idea. I have to have a common denominator to find the difference. The quickest denominator is 6 times 8, which is 48. And then I cross multiply 8 times 1, 6 times 1. Remind myself I am subtracting this time. 8 minus 6 is 2 out of 48. And then I notice they're both even, so I can reduce. 2 goes into 2 once, 2 goes into 48, 24, so that should be the difference between them. Now, the book goes over a different method where you find the lowest common divisor, and I can show that in a little bit. That's a bit more work. I think this is a better method, the arrow method for adding and subtracting. So we trade a smaller denominator for having to reduce more often. And I would rather reduce than try to find a smaller denominator. Okay, Savannah wants 57. That's section 4.4. Oop, button.
Do we only do the arrow method when we don't have matching denominators?
Yes, if the denominator's matched, we're fine. You don't have to do it.
And we don't have to do any trick with the subtraction?
Yeah, so if so let me come back to this in a second. Let's go back here.
So like 21, 7/12 minus 1/12.
Yeah, so since it's the same size pieces, a 12th, I can just say 7 minus 1 is 6/12. And 6/12 happens to reduce, because I can divide top and bottom by 6 and get 1/2.
Okay.
Yeah.
All right, thank you.
So if there's not a common denominator, arrow method. If there is a common denominator, it's keep the denominator, subtract the numerators.
Okay. And you keep the denominator for addition too?
Yeah, addition or subtraction. Yeah. All right. Here we go. Let's do a couple of these. All right. So this specifically says use the least common denominator. So that means I have some work to do. So for 57, step 1 would be to find the least common multiple of 36 and 54. And I'm going to do this using a factor tree. So I would start with saying 2 goes into 36 18 times. Then 2 goes into 18 9 times. 3 goes into 9 3 times. So I know 36 can be written as 2 times 2 times 3 times 3. Or I could write it as powers, 2 squared times 3 squared. Next, I have to do that for 54. 2 goes into 54. 25, 6, 27 times, I'm pretty sure. Something I should probably check in a calculator. 2 does not go into 27, but 3 does, because 2 plus 7 is 9. 3 goes into 27 9 times, and then 3 goes into 9 3 times. So that means 54 can be written as 2 times 3 times 3 times 3, or with powers 2 times 3 to the third power. Then to use those to find the least common multiple for the denominators, I start with the first one and I just write down what its prime factorization is. So I'm just going to write down q squared times 3 squared. Then what I do for the second number is I ask myself some questions. Is there anything missing? So what's missing for the second number? Are there enough 2's here? The answer is there are more than enough 2's. I don't need any more. I'm good on 2's. Are there enough 3's up above? And the answer is, oh, I don't have enough 3's. I need to multiply in another 3. Cleaning that up, that's going to be 2 squared times 3 cubed. And if I multiply all of that out, that's going to give me 2 times 2 is 4. 2 times 3 times 3 is 27. Oh. I need a calculator help for this one. Let's see, 4 times 27 is 80. 28, I think that's 108. So that should be the lowest common denominator or the lowest common multiple. The rule here for the lowest common multiple is choose the highest power of each prime. So we're putting numbers to find the lowest common multiple. We first have to do a factor tree. I recommend writing it in powers. And then look at those and find the highest power of each prime. So the highest power I see here of 2 is 2 squared. The highest power I see here of 3 is 3 cubed. The smallest denominator has to be 2 squared times 3 cubed, or 108. A lot of work. That's what we had to do. All right, we're halfway done with this problem. Shift this up a little bit. So next, to use that, I have, it's right in green, 7 over 36 plus 11 over 54. I have to ask myself, how many times does 36 go into 108? And I kind of have a clue on that over here. This number right here is my 36. I had to just multiply by an extra 3. So I'm going to find that is 3 times. So I'm going to multiply by 3 top and bottom. Similar, I have to ask myself, how many times does 54 go into 108? And I've got some clues over here. 54 is 2 times 3 cubed. Up here, I have an extra power of 2, and we can check on the calculator. It goes in 2 times. So now I have to multiply 2 here. The reason is 3 times 36 is 108. And 2 times 54 is 108. adjusting the numerators, 7 times 3 is 21. 2 times 11 is 22. My common denominator is 108. I have 21 and 22 of them, which is 43. That's a lot of work.
Can you use the arrow method?
You can use the arrow method.
We gotta break
I'm going to
it
do that next, but
Okay.
yeah, so then there's more breaking down. Okay, so this problem specifically said use the least common multiple method. It's not my favorite method. The book does a few examples of it. And again, somehow you have to find the lowest common multiple. This is one way to do that. After you find the lowest common multiple, you have to figure out how to adjust each fraction. And then you can finally add. So I'm going to do the show you what the arrow method looks like for this next. It's not quite as much work, but it's still a lot of work. So I want to add 7 over 36 to 11 over 54. If I use the arrow method, I have to multiply 36 times 54. I'm going to do that off the side here. 6. Let's see, 4 times 6 is 24. 6 times 5 is 30, plus 2 is 32. 3 times 4 is 12. 3 times 5 is 15, plus 1 is 16. 4, 4, 7, 8, 9. Got a big denominator. 1, 9, 4, 4. Then I have to cross the 54 times the 7. 7 times 4 is 28. 7 times 5 is 35, 6, 7. And then I have to do 36 times 11. That's not bad. 6, 3, 0. 1 times 6 is 6, 3. So I get 396. Fill those up. Your denominator is 1,944. Let's see what happens if I add 378, 396, 8 and 6 is 4, 17, 7. So then I get 774 over 1944. All right, so look at the work I did there. Now, not reduced yet. Look at the work I did there versus look at all the work I did here. So far, I did a lot more work with the lowest common multiple version. Done. Okay, just give me a minute. We're going to try and minutes. Can I reduce that? They're even. Yeah, divide by 2. That's what I would do first. 2 divided by 2. Okay, so that's a little bit of work. Let's see. 2 goes into 774. 2 goes into 7 3 times. 2 goes into 17 8 times. 2 goes in 14 7 times. And then I'm going to get 387 over 2 goes into 1944. Let's see, 2 goes into 19. 9 times. 9 times 2 is 18. 2 goes into 14 7 times. 2 goes into 4 twice. So then I get 972.
That's reduced.
I don't know. The top isn't even, so I can't divide by 2 again. Could I divide by 3? You remember the trick for checking to see if 3 goes into a number? You add up the digits. So if I take 3 plus 8 plus 7, that's going to give me 3 and 8 is 11 plus 7 is 18. Yeah, 3 goes into 18, so 3 should go into that. And then 9 plus 7 is 16, 17, 18. 3 goes into that too. Yeah, so next I would divide by 3. And I'm running out of room. Slide it up and then come back. Oh, no, slide it over. There we go. 3 goes into 387. 3 goes into 3 once. 3 goes into 8 twice.
129.
129.
Yeah.
Yep.
And then 324.
Well, word for that. Which is it's not what we got over there. Not done yet, apparently. Oh, 3 goes in again. Slide it over a little bit. One more try. 3 goes into 12 4 times. 3 goes into 9 3 times. 3 goes into 3 once. 3 goes into 2 0. 3 goes into 24 6 times.
108. 324.
8 times. Shit. Shoot. Sorry. Okay, so no matter what, it's a lot of work. With the arrow method, you do get a quick answer. It's just not reduced. With the lowest common multiple, there's a lot of work that goes into finding the lowest common multiple. For me, that was all of this work here. And then I had to use that to adjust the fractions so I could finally add. Now this one didn't happen to reduce, but sometimes even with the lowest common multiple, you still have to reduce. Fortunately, there's not many like this in the homework. There's only a few. All right, you're done, Shay? Okay, I'll see you later.
I have a question.
Okay, so let's see, we got a question on 120. Okay, you have a question. I got a question there. You got something for me there. Did Makai finish there?
Yes.
Okay, I'll take a look at that in just a minute. All right, how are you guys doing up here? What you working on? You got a bunch of stuff? Oh, doing those to double check them. Okay, good. Excellent. Yes. Okay. And then I have a question for you. I had a piece of paper without a name on it. Here. Oh. You're in. Okay, good. Yours, I'll give it back to you.
I figured it out.
Figured it out.
Yeah.
Oh, awesome. Awesome. Okay, so that was 2-1.
Did they write my name on the bottom?
Don't see your name on there anywhere. Alexis 2-1. Okay, I got it written down. And you did pretty good. You don't need to redo anything. Just check out the ones that I said you got wrong with the right answer.
Okay. So, let's see here.
That's something that you didn't.
Yeah.
Okay, so that was the practice.
Oh, there.
Yeah, that one's okay. Yes, you got enough wrong on this one that I wanted you to redo just those
Okay,
that you
so,
got wrong. You don't have to redo the whole thing.
okay.
Just any problem, you don't have to write it. Yeah.
I didn't even have the papers, I'm just going over the ones that I got wrong.
Okay.
Wrong from the back, and I'm gonna finish this, and then I'll send it.
Okay, sounds good. All right, let's see. I'll be right over there. Got this.
That doesn't look promising.
I don't know yet. I'm just starting. Okay. Some work that goes with the last few.
Sorry, they're not in order. Just figure at the bottom.
That's good.
I'll get those caught up and then I'll probably email you a picture of them.
Okay, that sounds good.
And then the same goes for me, either that or I'll drop them off to the boss.
Okay. Do you guys have another class now, or you gotta run for something?
I gotta go check with the front office on something because I got an email.
Okay,
As
if you, okay, and if you're around today, the tutor is in the math cafe if you need help with stuff.
Okay, thank you so much. We appreciate it. You have
Okay.
a wonderful day.
You too. Okay. Same problems before, so we work on the loss thing. So just take a look at what I wrote here. Sometimes I wrote loss, ADP, off. All right, let's see, Mackay next, and then I have a question on 4-1. Button. 4-1. Number 29. Okay, yeah, that one I can do quick, and then I'll get to Mackay here. This one is a little confusing. So this is 4.1. So express 3 as an equivalent fraction having a denominator of 24. So first thing I'm going to do with 3 is rewrite it as a fraction. So 3 is the same as 3/1. Next, I need to figure out what do I multiply by so that the new denominator is 24. Well, the only thing I can do there is multiply 1 by 24, which means I have to do the same to the top. So then 24 times 3, 12, 6, 72. So 72/24 is the same thing as 3, is what I did there. Okay, Kai's turn. Okay, may I? So this, when I think about it, is if they're different in sign, it's a fraction. Or loss. it's me.
Okay. I remember that a long time ago.
So that number line can help. So
So I can fix those.
Yeah. So double check these now. I'll
Okay.
come back.
Can I change the board next week? Or,
Yeah, that's fine.
Oh.
Yeah, no rush. Let's see, everybody left me on wrong. Oh,
I have a question.
Yeah.
I'm
I'm gonna stop this and close it. Oh, I forgot to turn off the recording. I'm recording on me walking around. All right, we'll clean that video up later.